Okay, so first of all, we are going to learn about the nuclear atom. Okay. So the structure of an atom initially was discovered by the alpha scattering experiment. Okay. Okay. In an alpha scattering experiment, the other name for this experiment is also the Rutherford experiment. So don't be confused if something like that comes. Okay. Now, so in that we had an evacuated chamber. Evacuated chamber means that there is no air, there is only vacuum inside. Now, in the center we had a gold foil, and then through one side there is an alpha particle emitter. Now, for now, alpha particle basically is a helium nucleus of +2 charge. Alright, so it's positive particle. Now, so what happened was that when the alpha particles were directed towards the gold foil, three different things happened. Now, most of the particles either went straight or they were deflected at very small angles. Some particles deflected at large angles. And some of them, like very few, deflected backwards. Alright, so this happened. Now, so basically, we're gonna learn about the deflection. We're gonna look at the observation and about this deflection, and then we're going to learn about the conclusion. So deflection was 0 to 10 degrees, and observation was that most of the particles went undeflected or deflected at small angles. Then we had like those particles which went at large angles from 10 degrees to 90 degrees. And about these, we basically learned that some particles deflected at large angles. So originally, in the original experiment, 8,000 particles were incident to it, and almost out of 8,000, like 8 or 10 particles deflected large angle. Otherwise, all of them just went straight. Is that clear, everybody?
Yes, sir.
Then those which went back which was 90 to 180 degree. So very few deflected backwards. And they were like, out of 8,000, they were like 1 or 2. So that small number. All right. Now, keeping that in mind, then, the conclusion that they provided was that the atom consists of mostly empty space. And that is basically somewhat true, because when you look at an atom, like suppose the atoms of the gold foil was surrounded like this, right? So if you look at an atom, most of it is just, nothing. So the particles which were directed, they either went straight, or which were like a little bit closer to it, they deflected a bit. Is that clear?
Yes, sir.
Then the conclusion about 10 to 90 degree, why some of them were deflected large angle, because they said that all the positive charge in a nucleus, in an atom, is concentrated at the center, which means that those particles which came really close to the atom, they were deflected at large angles. All right. Now the reason why very few of them, basically very, very few of them, deflected backwards was because in an atom, a nucleus at the center contains all, in fact, let's write most of its mass. That would be more appropriate, which means that only, because the nucleus is so small that only few particles could reach at the front, and now they can't break the nucleus, so they had to turn back. Understood? So nucleus is so small that out of like 8,000, only 1 or 2 managed to come directly in front of the nucleus. Everybody understand this?
Yes, sir.
Good. Very nice. You can write this down, please, and then we're going to go forward.
Can you explain this again?
Okay, what I'm saying is that, like, an atom literally has nothing in the surroundings, right? So particles just went straight if they're not close to the nucleus, or deflected at very small angles, because of the positive charge, right? But that's very far. So those particles who came close to the nucleus, they were deflected large angles because nucleus is also positive and alpha particles also positive. And those particles which directly came in the front of the nucleus, they can't just break it, so they have to go back, right? Because of the repulsion between positive and positive. So what we learned from this is that nucleus, we're learning the structure of the nucleus. Then nucleus is basically positive. It is very small, and almost all the mass is like concentrated in it. Do you understand, Travis? Otherwise itself, if you look at the structure of like atom itself, atom is comparatively very large when we look at the nucleus. Understood? This is just for this is just for your understanding that the diameter, like today we know that if this is the nucleus, right, and this is the atom, so the diameter of a nucleus is about 10 raised to power minus 15. It's so small. And the diameter of atom is 10 raised to power minus 10. So basically a nucleus diameter is like 100,000 times smaller than the atom. Understood? Okay, Chavez?
Yes.
Yeah. Today we know this. Yeah.
Sir, in the first one, why did it reflect a bit that?
Because the space between the ends of the nucleus and the center of the nucleus is too much. You get my point? So there's so much space that particles can just go mostly straight, okay? A little bit deflected. Yes. Yes. Who's HP? Do I know somebody HP? Moise, everything is clear? And Zainab, Hussein,
Yes, sir.
Rabia? Okay. Rohan. Rohan, weren't you in
Yes, sir.
the basic class? How come you're in here? You shifted?
You said you told me to also take these ones.
Oh, you're going to appear for the exams. Oh yeah. So why aren't you taking the basic class then?
I am not.
No.
Sorry.
Okay.
Sorry. What did you say?
Why aren't you taking the basic session then?
Should I take that also with these classes?
If you want to, that's fine. Otherwise, we're going to just repeat it very, very soon. So it's fine. You can just take one. That will be too much. Okay,
Okay.
Chavez, is that clear? Everything is clear? Everyone, should I move forward now?
Yes, sir.
Okay, now. So the thing is then, keeping that in mind, today we know that when you look at an atom, right? No matter which element is this, suppose element X, it has two values, Z and A. This value on top is the atomic mass or the mass number. You might, those who take chemistry would know, and this is the atomic number, which is also the proton number. For example, if you look at carbon is given by 16. Oh my god, I was writing oxygen. Oh no, 12 and 6, right? So basically it means that carbon has 6 protons, 6 neutrons, and 6 electrons. Do you guys understand this?
Yes, sir.
Because
Yes.
mass number is like, protons plus neutrons. This is the mass number. Now, carbon can have its isotopes as well. Isotopes are basically defined as the atoms of same element with same proton number. Oh, same proton number but different mass number. Mass number, or you could say number of neutrons. Okay, it's up to you what you want to write. So, like carbon has an isotope like 12, carbon other isotope is 14, there is also carbon 13, so these are isotopes. So all of them have 6 protons, that's how we know this is a carbon. But this one has 8 neutrons, this one has 6 neutrons, this one has 7 neutrons. So different neutron number. Understood? Now the most stable form of an isotope is basically written in the periodic table. In physics we don't use periodic table, so you don't have to worry about that. Now we got ions as well. Like for example, if you see an element like oxygen 16 and 8, so currently it's neutral. When we say it's neutral, because it has 8 neutrons, 8 protons and 8 electrons, because they're like in the same number. But if this was oxygen 16 8 and there was like a positive one here, that means that now it is a positive ion, and a positive ion means that it has 8 protons but it has 7 electrons. So how does something become positive? Because it has lost one electron. So an element can gain or lose electrons, it cannot gain or lose protons because they would just be the same. Okay, now similarly, if there was oxygen 16 8 and it was -1, then now it is a negative ion, which means it has 8 protons and 9 electrons. So why is it a negative one? Because it has gained 1 electron. Except for that, how do they gain? Whether they gain or not, whether they're donor, etc., whatever they are, that is told by your chemistry teacher will tell you. I can't tell you that. Is that clear, everybody?
Yes, sir.
Okay, please write this down. This is very, very important. Okay, now let's look at the 3 things. Now, with respect to a proton, a neutron, and an electron, I just want to tell you, proton has, we're going to talk about the relative mass, we're going to talk about relative charge, and I'm going to move this to this side. Okay, so for proton, the relative mass is 1, neutron is also 1, electron is 1 upon 1840. Electron is very, very less massive. Proton has +1 charge, neutron has no charge, and electron has -1 charge. Alright, you can just write it down. General notation about these ones are that proton is written as 1 and 1, neutron is written as 1 and 0, electron is written as 0 minus 1. Sometimes we also write it minus if you like. That's fine as well. All right. Okay. Pretty cool. Let me know if you guys understand this.
Yes, sir.
Okay, perfect. Perfect. Okay, give me like 30 seconds now. Okay. Now, so now that we know about the nucleus and we know about how it is there, we're going to talk about some of the particles which basically are important in the sense that there are three types, right, of types of radiations, and then we're going to look at them. So first of all, we're going to talk about the alpha particle. Then we're going to talk about the beta particle. And then we're going to talk about the gamma particle. Oh, gamma is not particle. Okay. Gamma radiation. Alright, now it would be a particle as well. Anyway, so when we are looking at them, we're going to talk about their symbol first. We're then going to talk about their nature. In 10 minutes, please rejoin, okay? If you've not finished this, by the time I think we'll be finished. We're going to talk about their ionization. Ionization. We're going to talk about their penetration. And their deflections. All right. Yeah. Now check this. The symbol of alpha particle is like, of course, A. It has 4 mass, 2 charge, and of course plus 2. Usually we write it like this. Beta particle is like B, 0, -1, and gamma is like a ribbon like this. Okay, it has no charge, nothing. The nature is that this is like, okay, I should have colored this. This is not fair. And the thing is, the nature is, it is a helium nucleus. This is a fast moving electron. Gamma is basically electromagnetic radiation. Okay, now their ionization is that this is highly ionizing, which means that it can gain 2 electrons. This is moderately ionizing. It can provide an electron because -1 charge, and gamma is little to none ionizing. So it can only knock out something or provide kinetic energy. and stuff like that. So you don't have to worry about that. Penetration, it is very heavy, so it has a very little penetration. And the most important thing is that can be stopped by paper. So that much it has. It has moderate penetration. It can be stopped by aluminum. And then we have gamma. Gamma is high penetration, right? That's very important. So can be greatly reduced or stopped by lead. Okay, like that. Is that clear, everyone?
Sir, could I please find it and disconnected?
Yeah. So alpha particle has a very little penetration. All right. So if you place a paper in front of it, it cannot pass through that. For beta particle, if you place aluminum, it cannot pass through that. And if you place lead in front of gamma, so depending on the thickness of lead, it can be reduced or completely blocked as well. Is that clear?
Yes, sir.
Then deflections, because these two are particles, so this is deflected by electric and magnetic field. And of course you can use the left hand rule to use in magnetic field and plus minus sign to see where it will be deflected. Beta particle can be also deflected by, we are also going to draw diagrams later, electric and magnetic field. Any charged particle will be, so they will do. But this is undeflected because it has no charge. It has no mass and no charge. Understood?
Yes, sir.
Okay. You can just add on something here. We'll also add, let's just write that last, and then we'll continue this tomorrow, because tomorrow we have to do big stuff. Okay, so mass of alpha particle is relative mass. Basically we're talking about 4, charge is +2, it is 0 and -1, and it is 0 and 0, no charge, no mass. Okay, you can draw this, you can write this, and when you're done, let me know. Okay. From this point onwards, we're going to learn this. We're going to do it tomorrow then, because I need a lot of time to do this. You still did not tell me who's HP. HP? Who are you?